Hey guys, all right. Today we are going to take a look at what's called epidemiology. Epidemiology is a synonym for pathology, but just slightly different. As again, pathology, as we've maybe briefly mentioned, and we'll touch on a little bit later too. Pathology, the term path means disease. So pathologists are just really kind of studying all diseases. Epidemiologists, however, really focus on infectious diseases. And in this chapter, we'll take a look at what epidemiologists do, some terms that we may see in that study of epidemiology. This chapter is actually for those of us that are, experiencing the COVID-19 pandemic right now. We're actually going to see the term pandemic, and we're going to see how it compares to terms like epidemic and endemic. And I'll show you exactly what I mean by that. So we'll see a lot of terms like that and comparing, again, what epidemiologists do. Let's take a look. All right. So let me share my PowerPoint with you here. All right, here we go. Let's take a look. So chapter 11, we're looking at epidemiology. So epidemiology is what we're going to look at first. We're going to define that, and I'll explain, exactly what that is, as I've kind of already done that. But we'll take a look at interactions among pathogens, hosts, and the environment. We'll take a look at what's called the chain of infection. Part of the chain of infection would include reservoirs and the modes of transmission. So really what we're going to take a look at is how infections spread. So we're already kind of familiar with this, as we're pretty familiar with the spread of infections and how we can break that chain of infection, but we'll touch on that. Then we'll take a look at public health agencies, and we're actually going to end the chapter there. So we don't get into bioterrorism and warfare agents. So we don't need to worry about that. Okay, but let's take a look. So our introduction here. So again, we're looking at the term epidemiology. What epidemiology is, it can be loosely defined as, again, the study of disease. Very similar to, again, pathology. So very synonymous with pathology. Epidemiologists, again, are the ones that are studying these factors that determine the frequency, distribution, and determinants of these diseases in human populations. So they're the ones who are focusing on, how often do these diseases occur? They measure, on a yearly basis, we normally see this many diseases. On a monthly situation in this particular location in Louisville, Kentucky, or in in this particular geographical region like the United States. These guys are the ones who are really focusing on what is a normal year or month or week or whatever look like when it comes to disease. And then what happens is when we see some abnormalities, like maybe we see an increase in the number of cases and things like that. So let's take a look. So epidemiologists are also, their focus is to help to prevent, control, and eradicate these diseases. So we're trying to get rid of these. If you remember, or you all may not remember, but way back when we had diseases such as smallpox and polio, and these diseases are no longer part of our population because epidemiologists work so hard to create vaccines and to get vaccines distributed and make sure that we no longer see smallpox anymore. Smallpox was eradicated in 1976, so not that long ago, but it was something that, again, existed, in that time period, and now no longer does because of, again, these guys that are working so hard to eliminate this and to eradicate these. So let's take a look at a couple terms that we'll see here. So communicable versus contagious. We probably so often have heard the term contagious when we talk about how a disease can be spread from one person to another. That's actually the definition of the word communicable. That a disease that is infectious, that can be transmitted from one person to another, is called communicable, meaning that it has the ability to communicate from one person to another. The term contagious, however, we add one word to that definition, and it's this E word right here, easily. If a disease can be easily transmitted from one person to another, that's where we bring in the term contagious, meaning that it's much more easy to spread that disease than a communicable disease. So again, they're very interchangeable, but the difference is that one word, that it's a little bit easier to spread a contagious disease. The term zoonotic, so we can see the prefix zoo right there, or zoo, like where we keep animals, right? These are diseases that can be acquired from animal sources. So we'll see a lot of examples of zoonotic diseases a little bit later in the chapter, but that term, again, easy to hopefully remember because of that zoo prefix there. So we associate that with animals. All right, incidence. We've probably heard this term a lot recently, but the incidence of a particular disease is the number of new cases of that disease in a defined population during a specific period of time. So I'm going to probably use the example of COVID-19 in this chapter. I'll probably use that a couple times because we are so familiar with that as we've experienced that. But in our specific population, so in Louisville, Kentucky, often, epidemiologists are studying how many new cases of a disease are being reported each day. And that happened every day with coronavirus. Every day, for those that live in Louisville, Andy Bashir came on and said, okay, in Kentucky, we have this many new cases. In Louisville, it was this. In, Warren County, it was this. In Hardin County, it was this. So that's what that is. Those are incidences, those number of new cases. So we have so many new incidences of these diseases. That's the number of new cases. The morbidity rate is actually pretty similar. It's a number of new cases of a particular disease that occurred during a specific time period per a specifically defined population. So really kind of the same idea. The term that I will actually use more frequently, so I'll tell you, is incidence. Morbidity is typically used when we're talking about something that maybe occurred previously, that we're talking about the morbidity rate of, back in 2019 or whatever, sometimes we refer to it that way. The morbidity rate was this, that we saw this many new cases. Excuse me. Typically incidence and morbidity can be one and the same, but it's kind of that specific defined population. But I will use incidence more often just because that's what we will see more often. So I would focus on that term, incidence. Prevalence, so you don't really need to worry about the difference between point prevalence and period prevalence, but we hear the term prevalent more often when we say that a disease is pretty prevalent in an area, meaning that it is, we see more cases in that region than we do others. That means it's spreading more, or there's just more people with that disease in that area. It's more prevalent in that population. So that's what that is it's the number of cases of a disease existing in a given population in a given period of time. So period and point, again, is the specific time or at that particular moment in time. You don't have, again, you do not have to know the difference between the two, but that's where we typically will hear the word prevalence. That is, something is more prevalent in an area. We're seeing a whole lot more cases than other areas. So it's kind of comparing the two. Incidence is, again, something we will see more often, but that's where we'll see the term prevalence. And this one is pretty easy to define as far as the difference between those other terms when we come into epidemiologic terminology. Sorry, I can't speak today. But the mortality rate, definitely different than the morbidity rate. Mortality rate is the number of people who died of a particular disease. So these are people that, if you remember from, again, our governor coming on all the time explaining, we have so many new incidences of a disease, but today we also have this many deaths from coronavirus. That was the mortality rate being reported. So the mortality rate, again, the number of people who have passed away from that disease. Okay. So these are the terms, as I mentioned at the very beginning, when we talk about, again, what a pandemic is. These are the difference between those types of disease. There's 4 terms we're going to look at right here. And it's, again, kind of measuring the spread and what happens like as a disease gets, we're seeing it spread a little bit further. So let me explain that. So a sporadic disease. So when we think of the term sporadic, like if something happens sporadically, it's just an occasional pop-up of something here and there, whether we're talking about diseases or not. If we happen to, there are things that we do sporadically. It just means we do it on occasion. And that's what this means. With a sporadic disease, it's one that only occurs occasionally within a population of a particular geographic area. So an example would be tetanus. So again, epidemiologists, so for instance, let's say epidemiologists in Louisville, Kentucky, they're specifically measuring Louisville, Kentucky, and what normally happens in a given period of time. They expect a sporadic pop-up of tetanus every once in a while. It's not something that we see all the time, but every once in a while, it's normal for tetanus, somebody to pop up with tetanus. So it's very sporadic, just every once in a while. Whereas an endemic disease is one that is always present within a population of a particular geographic area. So an example would be gonorrhea. This is one that at any given point in time, someone in this particular geographic region has gonorrhea. Someone in Louisville, Kentucky. An endemic just simply means that it is something that is ongoing. Someone at this point in time has that. Whereas if that were to grow, we're seeing a whole lot more cases than we normally do of, let's say, gonorrhea, then this becomes an epidemic. An epidemic is defined as a greater than usual number of cases of a disease in a particular region within a very short period of time. So they use the Legionnaire's epidemic of 1976. But we've had, even in Louisville, Kentucky, recently, we've had a flu epidemic in Louisville and in Kentucky and Indiana. I believe it was actually like 2018 or 19. I want to say 19, where we had more cases than usual of the flu within this particular area. So it was defined as an epidemic because it was more than what we were used to seeing. But what happens is when that grows beyond our geographical region and starts to become something that occurs worldwide, that's where pandemic comes in. Pandemic is a disease that is now occurring in epidemic proportions, meaning it's still greater than usual number of cases, but it's occurring in many countries simultaneously. So the flu we had that actually broke out worldwide was the Spanish flu pandemic of 1918. So more than 20 million people were killed worldwide. And then the H1N1, for those of you guys who maybe remember that, in 2009 and 2010, that swine flu pandemic was something that was global as well. And then, of course, now more recently, COVID-19 is defined as a pandemic because it is something that has occurred globally. Okay, and some other examples will be HIV and AIDS, tuberculosis, and malaria. All were pandemics. Okay. So interactions among our, pathogens, hosts, and the environment. So again, whether or not an infectious disease occurs depends on a lot of different things. And a lot of you guys might be thinking, well, yeah, it depends on whether or not the pathogen, I come in contact with a pathogen, I wash my hands, things like that. You're exactly right if that's what you're thinking. So yes, so it's factors pertaining to the pathogen first. So one, the virulence of that pathogen, meaning how pathogenic is it? How easily spread is it? There's different factors that we actually get into a little bit later when we talk about virulence of, we'll talk about this actually next class, virulence factors that makes them, it kind of gives them their ability to spread and infect. So is the particular pathogen that we're referring to something that is virulent? Can it infect? The mode of entry, how does it get into our body? There are certain pathogens that really need to be in certain anatomical areas in order for it to cause infection. So the mode of entry into our body is going to depend on whether or not that pathogen colonizes. And the number of organisms. Again, if I touch the doorknob of somebody who had the flu behind them, I may or may not then go and wipe my nose, and I may get a couple pathogens from that very indirect contact there. Whereas if somebody's sitting next to me and they have the flu, I turn to talk to them and they sneeze directly in my mouth. Well, hopefully that never happens, but obviously that's going to deliver a whole lot more pathogens into my body, probably then activating that infection a little bit quicker. So factors all depending on the pathogen itself. Pathogens pertaining to the host. So meaning, Now, again, now that I have been sneezed on or touched that doorknob and wiped my nose, and now that pathogen has made its way into my body, it depends on my health status. And, have I been pretty sedentary? That sometimes causes our immune system to be weakened. What's my immune system like? Things like that. Nutritional status, my hygiene. Again, if somebody touches the doorknob behind somebody who had the flu, but immediately goes and washes their hands, we're good. So again, their hygiene, their age, as again, that what happens sometimes with age, why that's a factor. Babies and infants that are developing their immune system haven't quite developed that yet, so they're more susceptible to illnesses. Same thing with elderly, as their immune system is starting to weaken as they get older. Travel, so if you're traveling to different places that have different diseases that maybe the United States is not used to seeing, then your body's going to be exposed to something brand new. So your travel and your lifestyle are all going to be things that pertain to the host. And then factors pertaining to the environment. Some pathogens thrive in different environments. So physical factors such as climate, the season, some pathogens we see more so in different seasons, that particular geographic location. So like I said, some areas, we don't really see malaria much in the United States, but if we go to a country where maybe that is a little bit more prominent, we're now putting ourselves at risk of maybe experiencing that. Availability of appropriate reservoirs. I'm going to explain what reservoirs are in here in just a few minutes. Sanitary and housing conditions and availability of potable water. So we have fresh water that's not filled with bacteria and different pathogens. So all these things, so these really kind of three things I mentioned: factors pertaining to the pathogen, factors pertaining to the host, and the environment are all going to come into play on whether or not an infectious disease can actually occur. So there's 6 components in what's called the chain of infection. And the idea is hopefully this chain of infection breaks so that it doesn't spread to another person. But all these things must happen in order for a disease to spread. So first, there has to be a pathogen involved. So it has to be a disease-causing organism, obviously, in order for a disease to happen. Then the source of that pathogen, that's where the term reservoir comes in. A reservoir is simply, really a reservoir can be anything. The reservoir is where that pathogen has come from. So meaning, did it come from your friend that you're sitting next to that has that illness at the time? Did they take a drink of their water and then you took a drink behind them? Did they touch their phone and then you borrowed their phone? Again, a reservoir can really be anything. It can be a human, it can be an animal, it can be a bug that bites you after it bit an infected person. It could be an inanimate object. So we'll talk a little bit more about those reservoirs in just a second. The portal of exit, how does it exit the person who's infected? How does it get out of their body? The mode of transmission. So meaning after it exits their body, let's say they cough on their hand. Right now, it's just on their hand. It's not on you. But the mode of transmission, if they go and touch you, or again, it could be an indirect transmission where they go and touch something else and you touch behind them. Whatever it may be, that's the mode of transmission, meaning it's transmitted from the host or the infected person to the new host. And then the portal of entry is then how it gets into the new host. How does it enter into that person's body? Again, our skin is our first line of defense, that if I go and touch a doorknob and I have pathogens on my hand, pathogens typically aren't going to enter in through my fingertips, unless of course I have a cut on my fingertip, but then that may or may not occur. But it's kind of dependent on what I do next. If I go and wash my hands, or if I go and stick my finger in my nose, now we're going to have a problem. So that's the portal of entry. Now it's entered in through my nose. And then of course the susceptible host. Now it's going to also depend on my immune system, my hygiene, my nutritional status, things of that nature. My age, again, am I more susceptible to certain infections? So all of these things, and here's more of a visual example to show you that exact same process. All of these things have to occur in order for an infection to spread from one person to the next. So again, in this example, Andy is sick. So maybe he's not very visibly sick, so Bob is willing to shake his hand. He may not be actively displaying any signs and symptoms. And we'll talk about human carriers here in just a second on the difference between if they're in an active stage of illness or not. But Andy has, let's say, the flu. So that's the influenza virus is the pathogen here. The reservoir in this case is going to be Andy. Andy is a human carrier, so he is going to carry this pathogen. The portal of exit depends on what happened before he shook Bob's hand. Did he cough on his hand? Maybe did he sneeze? Or perhaps during this interaction, he coughs directly in Bob's face. It's just dependent on what happens here. So that's the portal of exit. How does that pathogen exit from Andy to then get to the mode of transmission here? The mode of transmission that I believe they're showing here, because we don't see him coughing or anything. Andy must have coughed on his hand and then now is now shaking Bob's hand. So that's the mode of transmission. It's a very direct contact here. We'll talk about different modes of transmission as well. Bob is now the susceptible host. So now it depends on what Bob does. Again, if Bob goes and washes his hands immediately, we may not have a problem. He has broken the chain of infection. But if Bob goes and wipes his nose, maybe he goes and makes a sandwich and then eats a sandwich, you just never know. That's going to be how it enters into Bob. And then again, the susceptibility of Bob, Bob's age, his nutrition, his immune status, his immune system is all going to be dependent on whether or not that infection causes an actual illness within Bob. So that's all the chain of infection, the 6 parts of that chain of infection. Let's break down those parts a little bit. So when I say the term reservoir, a reservoir, again, is pretty much anything that can hold a microorganism or a pathogen. So these are called reservoirs or reservoirs of infection, but there's very different kinds of reservoirs. Animals can be reservoirs, humans, and again, like I said, even your cup, your phone, your keyboard on your computer, all of these, again, can be reservoirs because they can hang on to pathogens. So these are living reservoirs that we're talking about first. So humans, pets, farm animals, even insects and arachnids. And we'll talk about each of these a little bit further. But human carriers, as we just saw with the example with Andy and Bob, Andy was our human carrier. Human carriers are carriers, whether they are in an active stage of illness. Oftentimes when we see a person who comes up to us and they're obviously coughing and sneezing, you can see they have a red nose and maybe watery eyes. You can tell that they're sick, and it makes you a little bit hesitant before you run up and hug them. But human carriers can be carriers even if they're not actively showing those signs and symptoms. So this is the difference between our different types of carriers. First is a passive carrier. A passive carrier is someone who is displaying no symptoms whatsoever. They are symptomless. So they may either, I'm going to use COVID-19 again, because some people have been able to pick up the coronavirus and been able to be asymptomatic and be able to spread it from person to person. So some diseases, depending on the person's immune system or whatnot, they still may be able to spread an infection, but not be displaying any symptoms. And that's going to be a passive carrier. In an incubatory carrier, in this case, what happens is when an illness occurs, and a lot of you guys may be very familiar with this. When we start to get sick, sometimes it begins with maybe just a tiny little scratch in your throat, or maybe you start developing a little runny nose. And that's the beginning, the very first symptom. You don't really know if you're sick or not, or if it's going to turn into anything more, but sometimes you can kind of tell that it might. That is when the illness is in what's called the incubatory phase in your body. It is slowly starting to build. And because you have that pathogen in your body, you are a carrier for that illness. So those minimal symptoms, you're in your incubation phase. So that's an incubatory carrier. Whereas a convalescence is when you are on the kind of on the upswing. that maybe you've had an illness and you're starting to recover and starting to feel better, but maybe you're not quite 100% yet. At that point, you are still a carrier because the pathogens aren't completely gone yet, and you may still be contagious. So convalescent means that the person has recovered, but still has the ability to be a carrier. And lastly, active, an active carrier, opposite of somebody who is a passive carrier. This is somebody who is actively displaying signs and symptoms of an illness. We're usually pretty aware that somebody is sick when we walk up to an active carrier. All right, animals. Again, animals have the ability to be a reservoir too. And remember, when an infectious disease can be spread from an animal to a human, this is called a zoonotic disease, or sometimes referred to as a zoonoses. Zoonoses may be acquired by either direct contact with an animal. So perhaps, it's something that you can get just by being with that animal. Sometimes it's a direct bite from that animal, or even an inhalation or ingestion of that pathogen. So sometimes beef that is not cooked very well sometimes has the ability to, if there's a pathogen in that beef, if it's not cooked, that pathogen isn't dead, and so it sometimes can cause an infection in our body. And sometimes even an injection of the pathogen by an arthropod, which would be an insect bite. So examples would be like rabies. Rabies, you guys, I'm sure have heard of. Lyme disease is when it can be passed by ticks, by deer ticks specifically. But again, only if that tick is carrying that disease. Not always if you get bit by a deer tick are immediately going to get Lyme disease. And the same thing with rabies. I say that because I was watching something on TV with my stepdaughter the other day, and somebody got bit by a squirrel, and she goes, "Oh my gosh, she's going to get rabies." And I said, not every squirrel bite means that they have rabies. The squirrel has to have rabies in order to spread that to that person. So again, it's they have to have that pathogen in order to spread it to you. But it is possible, and that's where it comes from. So when I say arthropod, an arthropod would be, again, where we see these different insects involved. So many different types of arthropods serve as these reservoirs, including insects, which would include fleas, mosquitoes, lice, and even arachnids like mites and ticks. Anytime these insects these arthropods are involved in the transmission of an infectious disease, they're referred to as vectors. So if you ever hear the term vector, I am still talking about reservoirs, but I'm specifically referring to insects being those reservoirs. So arthropod-borne diseases, Lyme disease that I was just talking about, that's spread by deer ticks. Again, the deer tick is the vector in that example. In malaria is typically spread by mosquitoes, where a mosquito bites an infected person, so has the ability to retrieve the blood of infected person, and then comes and bites me, now has the ability to infect me. So a mosquito would be the vector in that example. And again, pretty much anything can be a reservoir. So non-living reservoirs would include even the air and airborne infections, soil, dust, contaminated water, foods, and even what's called fomites. And it defines fomites there for us in the next bullet point. A fomite is an inanimate object that's capable of transmitting pathogens. So earlier when I was explaining your cup, your phone, your keyboard on your computer, in a hospital setting, that could be bedding, towels, eating and drinking utensils, hospital equipment, anything you can think of that somebody may have touched that now may contain that pathogen. Here is a visual example of some of those hospital fomites that you see that, again, an infected person could come in contact with and now has the ability to be a reservoir for that infection. So these are some fomites. All right. Now let's talk a little bit more about that mode of transmission. So again, mode of transmission, there's lots of different modes of transmission depending on the specific illness. Sometimes things cannot be spread depending on the disease. Like I'm going to use the example mononucleosis. For those of you guys who may remember what mono is, Mono is sometimes referred to as the kissing disease, but it can only be spread through that mucous membrane to mucous membrane contact. So again, either via kissing or drinking after one another, that can occur as well. Because of that. And so that's a more indirect contact, but it still can happen that way. But if I gave somebody with mono a high five, totally fine. Absolutely fine. Can't be spread that way. So it really just depends on the mode of transmission, or depends on the pathogen, I should say. Like we said earlier, the factors pertaining to that specific pathogen. So, but here are some examples of modes of transmission. So again, skin-to-skin contact. Illnesses can be spread by the high fives. Direct mucous membrane to mucous membrane contact through either kissing or sexual intercourse. Indirect contact via airborne droplets of respiratory secretion, so such as through sneezing or coughing. Indirect contact via food and water containing fecal matter. Indirect contact via arthropod vectors. So again, like I gave in the example with mosquitoes, mosquito bites one person, now comes and bites me. So I'm not directly contacting that sick person, but the mosquito is. Indirect contact via fomites. So again, I always use the example with touching a doorknob. That's a fomite, that I'm indirectly contacting that pathogen that has come from somebody else. And it's indirect because again, I'm not directly touching the sick person, but the sick person touched that before I did, and then I touched that doorknob. And then indirect contact via transfusion of contaminated blood or blood products by a parenteral injection, which is just an injection by needle using a non-sterile needle or syringe. So all kinds of different types of modes of transmission. And here's more of a visual example of all the things I just told you guys. So again, contaminated water supply and food, eating utensils are examples of fomites, dust that may make its way to that food, respiratory droplets, kissing, mucus to mucus contact, direct contact, arthropod vectors, there's a mosquito, again, animal bites, feces, in coming in contact with that, and parenteral injections. So all kinds of different modes of transmission there. All right, guys, and we're going to finish up chapter 13 with just explaining where these epidemiologists are located. So who are the individuals that are focusing on these studies? So first is the World Health Organization, abbreviated as WHO. You do not have to know that it was, excuse me, that it was founded in 1948, but it is an agency of the United Nations. And again, the difference between this one and the CDC that I'm going to talk about in a second, this is the World Health Organization. So they're focusing kind of globally. So their mission is to promote technical cooperation for health among different nations. So again, like I said, the different nations, to carry out programs to control and eradicate diseases and to improve the quality of life. So really very similar to what the mission of the CDC is going to be, but again, the focus is here, this is global. So the World Health Organization worked to investigate outbreaks of the Ebola virus. They helped to eradicate smallpox that I mentioned to you that was eradicated in 1976. And they're attempting to completely eradicate polio and draculanesis, but those you don't have to know specifically, but again, they're working to eradicate those. The main thing to remember is that it's a public health agency working across the globe, whereas the CDC mainly focusing in the United States. So this is the Center for Disease Control and Prevention. The federal agency is administered by the United States. This is the Department of Health and Human Services. You don't need to know that it's located in Atlanta and established in 1946, but very similar to the World Health Organization, but again, focusing here in the United States, working to collaborate to create the expertise, information, and tools that people and communities need to protect their health. So certain infectious diseases are known as nationally notifiable diseases, and so therefore hospitals are required to report them to the CDC so that we are aware of where these particular diseases are. So there is a morbidity and mortality weekly report that does come out and does explain, how many new incidences of new cases of certain diseases we have and how many deaths we have. So again, COVID-19 is a great example as we report that, during the COVID-19 pandemic, that's reported very often. Okay. All right. So the public health agencies, again, what they're working to do, their measures for prevention and control of these epidemics is to increase host resistance through the development and administration of vaccines. So again, that's the focus, is to make sure that we have vaccines being distributed so that people are immune to these illnesses. So that way that it induces this active immunity and maintains it in these susceptible persons. To ensure that persons exposed to a pathogen are protected against the disease. They work to segregate, isolate, and treat those who have contracted a very contagious infection to help prevent the spread. We're actually going to talk about that in the next chapter. We'll talk about what happens in a hospital setting when a person comes in with a very infectious airborne illness, how they're isolated in a hospital setting. So that's what these World Health not the World Health, but these particular public health agencies are working to try and do, is try to make sure that we're controlling it as much as we can. And then to identify and control potential reservoirs and vectors of these infectious diseases, so that when these infectious diseases do start to spread, we can advise the public what they need to stay away from, what they need to be careful of. All right. So guys, that is chapter 13. So looking at, again, epidemiology and what we're trying to do to eradicate these different diseases. As usual, guys, as you all know, if you all have any questions, let me know.